Good day and welcome to my YouTube channel. In this video, I am going to present my geometric model that I constructed entitled Octabloom. My name is Mark Maverick Mariano from BSEd Mathematics 3A. So let's proceed. This is the front and the back of my Octabloom. For the front, we have the elements A, B, C, D, E, F, G, and for the back, we have H, P, O, M, L, K, J, and I. So here are the moves that corresponds to each symbols at the front. For N, we will do nothing. For A, we rotate 45 degrees counterclockwise. For B, we rotate 90 degrees counterclockwise. For C, we rotate 125 degrees counterclockwise. For D, we rotate 180 degrees counterclockwise. For E, we rotate 225 degrees counterclockwise. For F, we rotate 270 degrees counterclockwise, and for G, we rotate 315 degrees counterclockwise. While at the back, we have H, where we will flip only the geometric model. For I, we will flip and rotate 45 degrees clockwise. For J, we will flip and rotate 90 degrees clockwise. For K, we will flip and rotate 125 degrees clockwise. For L, we will flip and rotate 180 degrees clockwise. For M, we will flip and rotate 225 degrees clockwise. For O, we will flip and rotate 270 degrees clockwise. And for P, we will flip and rotate 315 degrees clockwise. So here is the table of results when we operate a value star n. So if we operate n to itself, we still get n because the move is do nothing. Now, if we operate A star n, we will get A because first we will rotate the flower 45 degrees counterclockwise and then we will do nothing, which results into A. Now, if we operate B star n, we'll get B because first we will rotate the flower 90 degrees counterclockwise and then we will do nothing, which results into B. Now, if we operate C star n, we'll get C because first we will rotate the flower 125 degrees counterclockwise and then we will do nothing, which results into C. Now, if we operate D star n, we'll get D because first we will rotate the flower 180 degrees counterclockwise and then we will do nothing, which results into D. Now, if we operate E star n, we'll get E because first we will rotate the flower 225 degrees counterclockwise and then we will do nothing, which results into E. Now, if we operate F star n, we'll get F because first we will rotate the flower 270 degrees counterclockwise and then we will do nothing, which results into F. Now, if we operate G star n, we'll get N because first we will rotate the flower 315 degrees counterclockwise and then we will do nothing, which results into G. Now, if we operate age star n, we'll get age because first we will flip only the flower and then we will do nothing, which results into age. Now, if we operate I star n, we'll get I because first we will flip the flower and rotate it 45 degrees clockwise and then we will do nothing, which results into I. Now, if we operate J star n, we'll get J because first we will flip the flower and rotate it 90 degrees clockwise and then we will do nothing, which results into J. Now, if we operate K star n, we'll get K because first we will flip the flower and rotate it 125 degrees clockwise and then we will do nothing, which results into K. Now, if we operate L star n, we'll get L because first we will flip the flower and rotate it 180 degrees clockwise and then we will do nothing, which results into L. Now, if we operate M star n, we'll get M because first we will flip the flower and rotate it 225 degrees clockwise and then we will do nothing, which results into M. Now, if we operate O star n, we'll get O because first we will flip the flower and rotate it 270 degrees clockwise and then we will do nothing, which results into O. And lastly, if we operate P star n, we'll get P because first we will flip the flower and rotate it 315 degrees clockwise and then we will do nothing, which results into P. So next, here is the table of results when we operate a value star A. And then, here is the table of results when we operate a value star B. So if we continue this, we will get this table of results. Now, we must show that my geometric model forms a group structure. So, to form a group structure, we must consider the following conditions. First, the geometric model must be closed. Second is, it must be associative. Third is, it must have an identity element. And lastly, it must have an inverse element. So first, is my geometric model closed? So since the resulting elements were just found in the set N, A, B, C, D, E, F, G, H, I, J, K, L, M, O, P, therefore, the geometric model is closed. So, is it associative? So what we need to do first is we need to rotate the table by 180 degrees. So it will look like this. And then next is we will find a row or column that we can interchange so that the rotated table will be the same as the original. So as you can see here, we can interchange the rows 2 and 8, rows 3 and 7, rows 4 and 6, rows 9 and 15, rows 10 and 14, and rows 11 and 13. So if we interchange these rows, we will form a table like this. So as you notice, the rotated table is similar to the original table. Therefore, the geometric model is associative. So next is, does it have an identity element? So after examining the operation table, we can conclude that n is the identity element because the row and column labeled n both reproduce all elements in the same order as the set. So this means for every element x in the set, n star x is equal to x and x star n is equal to x, which satisfy the definition of an identity element. So next is, does it have an inverse element? So by examining the table again, we can say that each element has an inverse because for every element x, there exists another element y such that x star y is equal to n and y star x is equal to n, where n is the identity element. So this confirms that all elements have inverses in the set. So based on the operation table, we can conclude that the geometric model forms a group under the given binary operation. This is because the operation is closed as all results stay within the set. The operation is associative. There exists an identity element n that satisfies the identity property for all elements. And lastly, every element has an inverse such that their product with the element yields the identity. Therefore, all group axioms are satisfied, confirming that the structure is indeed a group.